All right, and welcome to our first webinar in the OperatorCon online session. Given the current circumstances, which probably everyone is aware about, we decided to move this online thanks to Lose. And also, this is actually a pretty cool schedule ahead. So I'm pretty sad to not see people in person because I really would have loved to have the discussions. But right now, if you look at the agenda here online, I think we have a pretty cool program coming up over the next week, starting today with our talk on challenges in building a multi-cloud provider platform with managed Kubernetes. So let me just switch over to the documentation. And then I think we can actually get started. Bill, did you resolve your technical challenges? And you're connected? Otherwise, I would just give another shout out to Lotse for organizing this entire thing and running OperatorCon. I hope you all saw the rescheduled date for KubeCon already. So I'm looking forward to seeing all of you in Amsterdam this fall. And having that said, I'll just jump in. I think we're having some technical issues and some limitations given the platform and current internet overload, but let's just get started. So as mentioned, we wanted to talk about challenges in building a multi-cloud provider platform with managed Kubernetes. What does it actually mean? What do we want to talk about? So kind of the TLDR, we as ArangoDB and especially Ewout and his team, we have been building a managed database service across multiple cloud vendors. And we wanted to talk about the challenges we saw when building that across EKS, GKE, and AKS. Of course, it sounds pretty easy. You have a managed Kubernetes solution and Kubernetes, the new abstraction for everything. So it should actually be pretty straightforward to port it between those different tools. And on the one side, it actually is pretty easy, but on the other side, there are still a lot of challenges ahead. So this is kind of what we wanted to talk about. So what we've been seeing and what we experienced over the past year, probably. And with me also still trying to join, given to technical challenges, is Ewout. He has been the team lead for the Oasis team. So Oasis is our managed database service here at ArangoDB. His background is mostly cloud and distributed systems. He's a big train guy, so if he doesn't program on either Kubernetes or ArangoDB, he's probably somewhere out dealing with trains, also kind of distributed systems. And you can also reach him on Twitter or the ArangoDB Slack. There's an entire team, so it's not just one person. There's an entire team behind this. So just shout out to Robert, Adam, Tomasz, Stanislav, Gerkley, and Ewout, who have actually built most of this. So I feel this is pretty amazing. And this is actually their knowledge they gained over the past year. I'm Jörg. I'm the head of engineering and machine learning at ArangoDB. Prior to that, my background is basically switching back and forth between large-scale distributed systems and in particular Kubernetes and databases. So for my PhD in distributed systems, I've basically been switching back and forth between some kind of Kubernetes or large-scale infrastructure project and databases for between each job. And so I'm really excited that right now here at ArangoDB, I can combine both passions inside one job. Why do we actually care? So this talk is mainly about Kubernetes. I think I have 2 slides about databases, but this is just to give you the background. So you might actually wonder, why do we care so much about Kubernetes? Why do we care so much about running on different managed Kubernetes solutions? So ArangoDB is a graph and beyond database. So at its core, we have a native multi-model. This means we can handle graphs, we can handle documents, we can handle key value, the same. So just imagine if a graph database and a document database had a kit together, this could basically be a ArangoDB. It's distributed, so it can, even our graphs, they can span multiple nodes, multiple charts. And this is kind of important if we talk about different deployments, because also our Kubernetes deployments has to support spanning across multiple nodes and actually making that safe. And anyone who has worked on distributed systems knows that that can be quite a challenge, especially given in a more fluent environment, which you typically get if you run on a managed Kubernetes solution. And if we look at the overall cloud-native landscape, so this is the CNCF landscape, we actually see that there are a lot of databases in there, including us. And the rationale for that is, at least from our perspective, if we look at our customers, where our customers and users deploy us, this is typically public, or this is often now in Kubernetes, on top of Kubernetes, or at least inside containers. From my point of view, especially Kubernetes operators, so we have one, we had one for like already a long time, and we also have like a lot of pulls on that already. This is mainly due to that both the Kubernetes concept, and then also if you have a decent operator, this is actually giving you a lot of leverage and makes the starting curve with a distributed database, which can be challenging, a lot easier, as both Kubernetes is taking care of a lot of infrastructure aspects, and then the operator can also take care of a lot of database abstractions. So let's talk a little bit about ArangoDB Oasis. So ArangoDB Oasis is our managed service for ArangoDB, and this is running in the cloud. So we are running on top of AWS, Google, Azure. We have fully managed deployments. So basically, once you start, you don't have to do anything. And we also have a highly secure model. So basically, leveraging the newest security technologies. And we are also highly scalable, running on those cloud providers and leveraging, obviously, ArangoDB underneath. We recently announced, so this is kind of the newest announcements from end of March, also the Oasis API and our Terraform provider. So for anyone who really likes infrastructure as code, this is pretty cool stuff where you can build your Terraform configuration, and you can also just leverage the APIs to control, to start new clusters, to scale new clusters, basically to manage your entire ArangoDB deployment on top of Oasis. A deployment, it's simply in its most basic form, it looks like this. You can configure a lot of different parameters. So what kind of sharding model do you want? Do you want like a one shard, which is like an optimized version, especially for graph queries? Do you want like a sharded version for really large data sets? How much memory should the nodes we provide for you have? And especially important for this talk is on what cloud provider do you want to run? So we have the same interface across different cloud providers. So across Google, across Azure, and across Amazon, I'm missing, yes. And this is made possible by the Oasis architecture. So we have two kind of concepts. And first of it, it's a data cluster. So a data cluster is where the actual ArangoDB clusters are running inside. So this is depicted here as a cluster customer deployment. So just picture that as like an ArangoDB cluster of varying size, depending on what you configured in the earlier dialog. So what you basically want. And we can have many of those across different cloud providers, across different platforms. And then this is basically, imagine there's one data cluster per kind of region per cloud provider. I think this is the easiest abstraction. Secondly, we kind of have a central control plane, mostly for us, to manage and control all those data clusters. So this allows us to see all the metrics in a single place. This allows us to handle different deployments, and it also allows us to deploy new data clusters. So imagine there is a new customer or a new user coming in who now wants a deployment over in Australia. We could start up a new data cluster from this control plane, and we can also see whether something is off in those data clusters. So as mentioned, this control plane, it's basically the brain. It's also running as everything in a managed Kubernetes on GKE. And this is basically hosting everything we need. And it also gives us a way to communicate with all the data clusters, and it's kind of like this central brain and central configuration hub for all of them. The data clusters, this is where kind of the actual work is happening. And the idea why we called it a data cluster was to abstract away cloud provider details. So we wanted for the control plane here to not really have to worry about whether one of those data clusters is running on AWS, whether it's running on Azure, whether it's running on GKE. And we mostly could do that, mostly. And this is what we see in the rest of this talk, where we kind of still have challenges around that. So those are specialized Kubernetes clusters as well, also running on managed Kubernetes solutions. But as already mentioned, this can be different cloud providers. So one might run on GKE, another might run on AKS. And so the data cluster creation, it's fully automatic. So we have an operator taking care of that. And this operator, so it's creating the actual data cluster. And this is actually specific for each cloud provider and really different. So this is what I mentioned earlier is kind of this abstraction layer for the control plane. All right, Kubernetes as an abstraction. So I hope we are all kind of familiar with Kubernetes. But for me, kind of the most important point about Kubernetes is that it gives us an abstraction. Already containers, they were this first step of giving us an abstraction. So containers in the real world, if we talk about them, which was always fun back at Mesosphere when we were in Hamburg, always talking about containers, or we would be sitting in a cafe, probably similar for the Lotse guys in Hamburg. And on the table next to you, someone was talking about containers. Probably they actually meant real containers. And we as computer scientists, we would always get happy that people knew about containers, but they were actually talking about those big boxes. And the idea behind those big boxes, why they are so popular, they're actually a really great abstraction. It doesn't really matter what's inside, but I can simply put it on a train, I can put it on a ship, I can put it on a truck, and it's basically abstracting away by having like a common interface to the outside. And just next, a container by itself doesn't really give us a lot. And so the next level on top to get value out of it is container orchestration. So container orchestration is taking care of a lot of different aspects. So container scheduling, making sure container restarts in case something goes wrong. It's taking care of resources, basically making sure each container is getting scheduled on a machine, on a node where it has sufficient resources available, and also some cluster-wide resources like Bill is trying to join. Just give me 1 second. Welcome, Bill. And so container orchestration is also taking care of resources, making sure everything gets scheduled on the right node. And probably most important, it's taking care of service management. By itself, typically, a container doesn't really help us too much. So if we, for example, look at ArangoDB, or it's the ArangoDB cluster on Kubernetes, we already have multiple containers running there. And I think the most challenging part is to actually connect and orchestrate them together, so kind of tie them together. And this is where container orchestration is really popular, or it's really helping us out as an abstraction layer. Probably the most known abstraction layer here is Kubernetes. And we all heard about Kubernetes. I assume that at least most of us the vast majority has even used it. And so this is kind of the second abstraction layer on top, which allows us to deploy those cool containers across any kind of infrastructure, across AWS, across Google, across Azure, or even across bare metal. So this is helping us, like, where can we deploy that? Where's the container abstraction is kind of hiding what's inside. The container orchestration abstraction is helping us. Where do we deploy that and how do we run stuff? If we briefly look at Kubernetes, we don't have to dive into too much detail. So there are actually multiple parts in that. So we have masters with the API server, scheduler, controller managers. We have our etcd cluster, who's kind of the configuration database, distributed configuration database of the cluster. And then we have actually the worker nodes where the containers are being executed and run. And we can already see this is actually quite some complexity there if we have to manually deploy that ourselves. I'm not sure how many of you have actually followed Kelsey Hightower's The Hard Way to Kubernetes, which basically goes through doing all of these steps, deploying a full-blown Kubernetes cluster in manual steps. And the second challenge coming in here is actually that typically we're not talking about a single Kubernetes cluster. A former colleague of mine and good friend recently said, Kubernetes clusters are like Pringles. You can't just have one. Typically, you end up with a large number of Kubernetes clusters. At its core, it should be like a production cluster. Typically, then you have a dev cluster, staging cluster. And even in production clusters, often you end up with multiple of those. And Ewout hopefully can elaborate later a bit more on how many clusters we actually have in Oasis. So given that, that complexity, we actually should rethink that second abstraction layer a bit, because we don't want to deploy so many Kubernetes clusters by hand. And this is where, at least for our managed Kubernetes service, we looked at the cloud providers. Basically, each large cloud provider nowadays has its own managed Kubernetes solution. So Amazon EKS, Google Kubernetes Engine, and also in Azure. So basically, we don't even have to deploy Kubernetes ourselves, but the cloud providers are already doing that for us. So cool. This actually sounds great, right? So what do we still have to do? Actually turns out quite a lot, and this is what the rest of the talk is about. So just in between, why do we actually care? Why didn't we just pick like a single cloud provider and said like, hey, Oasis is just going to run on AWS, Oasis is just going to run on Azure? So we have seen that often different customers have different requirements. So often there are company policies, and that can be either be in or exclusive. So there might be people saying, I really only want to run on Azure because we have a global agreement with them. They're a partner. There are other people who say, I don't want to run on AWS because AWS is also saying, or Amazon is also selling books. So they're actually a competitor. And similarly, often there are GDPR or in US CCPA requirements for like data privacy. So where can data be stored? Where can data be handled? Some people are also seeing that as a way to be like independent of like a single cloud provider, and they just want flexibility. Sometimes I even have the impression it's like a buzzword, multi-cloud. People have read it in some magazine and some online blog, and then CTO says, yes, this is really what we need, and we want multi-cloud. So I think these are the common reasons I've seen so far for people wanting multi-cloud provider setups. And so next, let's actually see what were the challenges. As mentioned, it really sounds easy. We get like a Kubernetes. Kubernetes should be an abstraction layer. So why isn't it just the same to actually deploy Kubernetes across all those different cloud vendors? Ewout, does your mic work now? Unfortunately, I still can't hear Ewout, so I would just continue. And if we get the mic to work, Ewout might just take over. So kind of first blowing of some steam. So imagine I had to write an email to all different cloud providers and tell them what I... Hi, Ewout?
Yes.
Oh, now it works.
Can you hear me?
Yes.
Awesome. So great. We had some technical challenges, but hey, we're technical guys anyway, so we get used to that. And let me continue off with some of the interesting challenges that we have for our multi-cloud infrastructure and how we deal with that. First of all, let's get all the nastiness out of there on slide 1. And we have some general abstraction on, we have done Google, we have done Amazon, we have done Azure, and what do we like and what don't we like. And as you can see from just the sheer size of the list, Amazon was actually one of the more challenging ones. But let's just go through them. So first of all, AWS, you have a lot of resources that are being created on the fly for you. So you don't really explicitly create them, but certainly when you are removing stuff, then suddenly there are all kinds of dependencies on these resources and you have to deal with them anyway. That is rather challenging because certainly AWS doesn't always tell you like, okay, this is the dependency that you need to get rid of. It just tells you there is a dependency. Good luck. We're not going to do it for you. So in order to get the cleanup part to function correctly, we had to have quite a lot of check this, then that, and so on. Other challenge for AWS is that some resources have tags, some don't. And we often use tags to store things like identifiers from our own side and so on. And it's great that you have that, but if you don't have that for some critical resources, you have to find relationship between the resources another way. That's challenging sometimes. And last, but certainly not least on the list of Amazon is the error handling part. The error handling is, I always say that is probably the most telling tale that AWS is by far the oldest in the whole list here. The API is huge and the error handling is not as sophisticated or more grown over time. So sometimes you have to check for codes, sometimes you check for strings and so on. You just want to have a simple checking message function like, does this error occur or is it this the case and so on, and that just doesn't happen there. Moving over to Google. Google is, at least the Google Kubernetes engine is by far the easiest to get started with. You just have a few APIs and you have a Kubernetes cluster running, and then you say, okay, great, we can do that. Until the point where they start updating your Kubernetes engine without your explicit knowledge that it's going to happen at that point. And since we're running, of course, databases, and the key nature of a database is that it is stateful, we sometimes need a bit more time than Google is giving us. So we have to be very careful that we stay ahead of the Google update machinery and make sure that it doesn't bite us that way. It's doable, but it would be nice if they would be a bit more flexible. Last but not least on the list, also for us it was the most recent experience that we had is Azure. And actually, we like Azure a lot for a lot of different reasons, but to be honest, it is the least mature. We see that in all kinds of features, scaling sets that cannot be scaled down to 0, for example, some issues that we had with persistent volume claims, and actually the list is quite long. But the good news is, and we really have to compliment Microsoft on that, is that their support was absolutely tremendous and they respond to us extremely quickly. Can you go to the next slide? Good. Okay. No, that one. Yes. What we want to give you is an overview of what kind of resources are we talking of when we are creating Kubernetes clusters in the various cloud providers. For AWS, the list is quite long. We have to do a lot. Nowadays, you could also use managed node pools. We're not using those. So we are setting up everything ourselves, the VPC, the gateway, net routing, all that stuff. It gives us the most flexibility in how to set things up, but obviously it means a lot of work to get everything up and running. And again, the resources that are created on the fly, you also have to get rid of. For GKE, it was really easy. Just a couple of API calls. You have a GKE cluster, a set of node pools, and that's it. And to be honest, that simplicity is great to get started, but once you are a couple of steps further, it is also tending to be annoying. An example of that is that on both AWS and Azure, we have full control over the cluster autoscaler, which is great. It allows us to do a lot. On Google, that control is not there. It's implicit by Google itself. And we would love to control that a bit further. So maybe we have to go more manual there in the future as well. On AKS, so Azure, things are slightly different. The concepts are more or less the same, but it's just everything is named differently. So you're not talking about node pools, but you're talking about VM scaling sets and so on. The great thing of Azure is the concept of a resource group. So within a single subscription, which is essentially an account or a payment account or a grouping, in that way you can have multiple resource groups, and you can say, okay, pack all these things together in a resource group, and if I want to get rid of that entire bunch, get rid of the entire resource group, and you cannot forget anything. That is absolutely a great feature. I would love for Amazon to have the same, but sadly that's not the case. But as I said before, the maturity is an issue. So one thing is we cannot scale down scaling sets to 0. That means that if we have a series of scaling sets, and scaling sets are the Microsoft equivalent of node pools, you have certain sizes, but also certain Kubernetes versions potentially. And what we would love to do is just say, okay, for every size of machine, we build a node pool, or in this case, a scaling set. And if we don't use it, we just scale it down to 0. That allows us that if there is a customer that wants a very big machine, we have just set it up. We don't have to do anything. If it's not there, we're not paying the cost for it. With Microsoft, we cannot do that because we cannot scale these things down to 0. So we had to come up with a more automatic management of these scaling sets ourselves, which is kind of cumbersome, but it's doable. The more problematic part is that for a single AKS cluster, there is a limit of the number of skill sets that you can have. So again, if you have multiple sizes of machines, then this number 8 is very limited, also knowing that a new Kubernetes version also introduces new scaling sets. So our typical approach would be when we update the Kubernetes version, we just add more node pools with the new Kubernetes version and then get rid of the old ones. If we do that on Azure, we just don't have the number of skill sets. So that's the problem. Next slide, please. Okay, so in general, Kubernetes as platform is great, but there is one downside to it, and certainly when you're using a managed version where the Kubernetes version is managed for you as well, you have to deal with that, and that is that Kubernetes, as we all know, is moving in a very rapid pace, and we just have to keep up. So we have to make sure that we are doing our upgrades, and there's a good thing for that, but it is a bit quick, to be honest. Next slide, please. Okay, so are there also downsides to using a managed Kubernetes cluster? Of course, we could have chosen to go for building our own Kubernetes clusters. As Jörg already said, you can do it the hard way, and it's a lot of fun, and you learn from it. But to be honest, you don't want to make a day job after that. At least we don't. And we are very happy with our managed Kubernetes clusters in general, but there are some side effects that you have to be aware of. And the most important are almost all related to the API server. There is very little control that you have over the settings for the API server, and that can sometimes be very annoying. For example, if you want to run some webhooks for authorization or have special command line options, if you look at the command line options for the API server, it's a tremendous long list. And it's very tempting to use all kinds of features there, but you cannot because they are managed by the cloud provider. So you have to deal with it yourself. Next slide, please. Okay, let's talk a bit about authentication and authorization. Just to give you an impression, at this time, we are running about 20 different Kubernetes clusters all over the world, spread over these 3 cloud providers. And that number is only growing. So I would not be surprised if we speak each other again in a year time that we have doubled, tripled, or even more increased that number. And here's where authentication and access control is actually a very fun subject. Well, not really, because every cloud provider has its own proprietary solution for that. If we are authenticating, we always, of course, use the same kubectl tool everywhere, but the authorization is different in all places. AWS is its own authenticator. For Google, you have the G Cloud, and for Azure, it's even different again. And that is just not nice to work with. Of course, there are some general mechanisms like webhooks and stuff like that. But as I said previously, we can't control the API server, so we cannot do that. Now, there are some projects out there that have made very elegant solutions, and we're in the process of adopting the same, and that is to make use of Kubernetes service accounts. And that is something that we will start using over the next couple of weeks, is that we use our own authentication mechanism in combination with standard service accounts. And then you actually have the best of both worlds. You have the flexible authentication and auditing that you want, and combine that with a standard way to access your Kubernetes cluster, no matter which provider it is. So we don't care anymore whether it's Google or AWS or whatever. We use the same authentication mechanism all over the place. Next slide, please. Another subject that you have to address when you're running anything Kubernetes related into production, or for that matter, any system in production, is you have to have logging. You have to know what is happening now and what has happened in the past. And also there, every cloud provider has its own system. These things are pretty expensive. They're different. They have different ways of working, etc. And if you just want to manage your system with one view, that's really annoying because you have different ways of doing it for the different cloud providers. But luckily, Grafana, which we probably all love and use for the dashboards, also has a very nice logging solution, which is Grafana Loki. And we are using that all over the place. So we're logging to Loki in the different Kubernetes clusters, and again use Grafana then to query it, to have alerts on it, and you name it. The same can be done for audit logging. Just a second. To a certain extent, we have the same problems again that we have with access control. So you need access to the API server in order to do that properly. But to a certain extent, we can extract the information already in our Loki systems. Yes, next slide, please. Okay, of course, a very big thing on databases is just storing your data. It's the most obvious feature that you have. And what is very important here is that you get, for a database, is that you get enough IOPS. And that can be a bit challenging, but in all honesty, we have quite good experience with all of them. But it is fair to say that AWS is by far the most competitive when it comes to performance at the moment. The rest is factors slower. But we also found some really strange things, primarily on AWS. We use standard volumes, so standard persistent volume claims in Kubernetes terms, obviously with provider-specific storage classes. And usually that system works very well. We didn't have a lot of problems until we started resizing Azure persistent volumes. That was actually a bit broken. The exact procedure in both Google and AWS, you can just say with a standard Kubernetes resource for resizing your persistent volume claim, you could resize it. But in Azure, there was actually a requirement that you would reboot the node to which that persistent volume claim was attached. Now you can imagine that if you have nodes with a lot of containers, that is pretty much a nightmare that you don't want to have. So with help, again, support from Azure team was great in this way. We found a manual workaround, but it was a bit sad that we needed that in the first place. And then we, of course, also have backup. Every cloud provider has its own long-term or object-oriented storage. So you're talking about S3 and GCS and so on. And we go around to use the native storage provider for every cloud provider. And that works out very well. Next slide. Okay. This is one of my favorite subjects, and that is networking. One of the challenges that we had is we are running multi-tenant data clusters. That means that we have Kubernetes clusters in which we run containers for multiple customers. That means, for example, if you're running in AWS, that you have a VPC, because the Kubernetes cluster requires a single VPC. And in there, you have multiple customers. A very big discussion item every time with customers is, I don't want my competitors or anyone else, for that matter, to see my data, which is a completely fair, understandable, and correct way of doing it. But that is giving us some challenges. And we were very lucky that Cilium was there at the right time for us to start using it. And Cilium, can you go to the next slide? Yes. What Cilium, if you go to the Cilium.io website, you can see that it is a network policy provider, and it allows you to specify networking rules, as generic as that. And these rules are implemented using BPF deep down into the Linux kernel. And what we do is we separate different namespaces from each other. So when we run databases for customers, we run every database in its own Kubernetes namespace, and we completely separate that using Cilium. But we're not only separating Cilium, these namespaces from each other, we're also separating these namespaces from the rest of the platform. For example, we don't want our customers to go anywhere near our metrics data, for example, or control plane information and so on. And with Cilium, you have control of doing that. So you can say, I want to allow network traffic to go into this namespace on certain ports, but it should not get out on this. You have all kinds of flexibility there. And since it is implemented in BPF, it is actually extremely fast. We have hardly any performance issues with it. And the only issues that we have in reality, and can you go to the next slide? Yes. So the only issue that we have in is that it should be cloud provider independent, but that's not always the case. There are tiny details that make it different. In the slightly older version, the current 7 version has been a improvement, but in older versions there were problems with a pod sitter range, so the IP range for pods on a node that were slightly different on AWS and Google. That meant that on AWS it could, the chance that you have when you're adding a new node, that it was running a pod sitter that was already in use, that was actually quite high. Certainly if your Kubernetes cluster became larger. And of course, that's not what you want, because you then get all kinds of strange network problems that are pretty hard to diagnose. Hey, these nodes are actually using similar IP addresses. That's not good. We had to make some to drain nodes if we detected that there were conflicts and so on. As I said, with the 1.7 version, that problem is pretty much gone, and it is an absolute joy for us to work with. We have often got questions like, why did you choose Helium and not Weave or anything else, one of the more known network layers? And we have chosen Helium primarily because of its low-level nature. The fact that it is running in BPF exactly on node level gives us the highest possible performance, combined with the highest possible shielding of work, and that makes it a great combination for us. Jörg, for the next.
Sure. The last thing on our list, and this is kind of like still open challenges, is something we're currently at in the future. Actually, a lot of people currently are, is kind of like container runtimes. I recently gave a talk about like who is who in this container space, and I'm not sure how many of the logos actually recognize, but I feel like at least with every KubeCon, there are at least like 5 new logos you can add here. And so for us, containers, they're kind of like a really great thing, but Ewout mentioned earlier, we care a lot about different isolation levels. And on the typically like on this one end of the spectrum, with like normal containers, just using C groups and namespaces, and we have like full-blown virtual machines giving us like much better isolation between different workloads, but on the other hand, also like much more resource overhead, and of course, then also the performance penalty. So what kind of has happened over the past, there have been like a number of new container runtimes on the one hand, and on the other hand, also like more secure containers. So for example, AWS has been pushing Firecracker. Google has been pushing gvisor, where they kind of like rewrote some bunch of the Linux kernel in Golang, which is pretty impressive. There's Nabla, and Kata containers. So I think there are like a lot of different ways which are kind of like in between the spectrum of like pure containers on the one end and kind of full-blown virtual machines on the other. So this is something we're currently looking at, and just seeing that different cloud providers, in theory, you should be able to run those across like any Kubernetes clusters, but obviously as different cloud providers are backing different projects, the integration into the managed Kubernetes solutions is different across different cloud providers. So this is something we're currently looking into, like how can we really isolate workloads even further on a container level. And so just to come to the conclusion, so in our experiences, if we kind of had to summarize that again, AWS, it's clearly older than GCP or Azure, and this is both good and bad. So in terms of like performance, API completeness, it's all there. But on the other hand, also like the API. So for example, eval mentions the error handling is also showing its age. So I think it's both. There are always like two sides to a medal, right? AWS on that, saying that is also like more in our experiences, so we had less network outages there, but it's also a bit slower to bootstrap, especially compared to like GCP. And from like if just from like a managed Kubernetes experience, GKE really gives you like a really nice experience, especially from the eye, like booting up like a new cluster there, connecting to it, just really is like flowing. It feels like really well sorted, well-designed solution. So I think this is kind of like this core thing we're seeing, that AWS is offering us a lot of different features, but it comes at like a price of having to work through like a slightly harder API here. All right, I think those were like our experiences. So thanks for listening. If you want to try this out in practice, there's a 14 free trial for ArangoDB Oasis. And ArangoDB is an open source project, so you can just download it, you can just docker pull it, run it on your own Kubernetes clusters. There's also the Kubernetes operator called kubeRangoDB. It's also open source, so if you just want to do it on your own Kubernetes cluster, feel free to go ahead. Both of us, Ewout and myself, we're still open to answer questions. So feel free to raise questions in the chat. And I would just give Bill one more chance to announce the remainder of the projects. Let's just see whether it works now. Hey, Bill.
Hey, how's it going?
Yeah, thanks. We managed to get you live. So if you just want to give like a little outlook of the next webinars coming up.
Yeah, so thanks so much for your presentation, Dai. Really insightful, and I think a really great comparison of all the different cloud providers. The next webinars are going to be every Tuesday going forward, so the 14th, the 28th, and May 5th at the exact same time, so 1700 CEST, so Central European Summertime. Next week, we'll be hearing from Nico from Ludsa about KubeCarrier, their new open source project around automated multi-cluster service management. On the 28th, we'll be hearing from Ken Owens from MasterCard, talking about infrastructure automation operators. And finally, on May 5th, we'll be from Nick Jones and Matt Jarvis from D2IQ, introducing Kubernetes operators the easy way. So once again, thanks for your time today, and I really appreciate the presentation.
Thanks for your questions. Feel free to reach out. Thanks so much for listening.
Yeah, and one last thing, the webinar is going to be recorded, and it'll be available on the Ludsa website under the resources and the webinars tab.